Okay, S2, Chapter 1, continuous random variables. First off, just look at the chapter heading itself. Continuous. What does the word continuous mean, either from your knowledge from S1 or from GCSE?
Can be any value in a range.
Can be any value, yeah, okay, great. Can be any value. So it's not restricted. Any value in a range. Okay. What's the opposite then of continuous? Discrete. Okay. Random variables. What do you know about random variables? Have you come across discrete random variables? Does that ring any bells?
Rolling a dice.
Rolling a dice. Okay. If you roll a dice, what can you have?
1, 2, 3, 4, 5 or 6.
You can have a discrete number of outcomes. And what can you associate with each outcome?
A probability.
A probability, yeah. So random variable is something that can take multiple values. So it can take multiple values at random, and it has associated probabilities. Okay. So what you should have done in S1 was discrete random variables. And the thing that Sam mentioned already was, for example, rolling a dice. Rolling a die if it's singular. If you were doing this and you would lay it out a special way, what was the proper way we could lay something out about this, the information that we have for this? If you were just thinking back to S1 and rolling a dice and the multiple values and associated probabilities, how might you draw it out?
Probability table.
Probability table, yeah, okay. You would say maybe that X is the value on the dice, or on the die, and then you would say X can take various different values, which we use as lowercase, and they would be 1, 2, 3, 4, 5 and 6. Then you say the probability that the random variable takes those values would be 1/6 if it was a fair die. And this thing here, what was it called when you had it drawn out like that? Can you remember? 2 words, one beginning with P, one beginning with D.
Probability distribution.
Yeah, that's good. That's right, okay. Once it's like that, that's probability distribution. Okay, so this is a recap from S1. The capital letter is the name of your random variable, and the lowercase are the values it can take, okay? So uppercase was used for the name of the random variable. And lowercase was used for its values. If I was going to graph that, what do you think would sensible labels on the axes might be?
X and probability big X is little x.
Yep. Okay. And what sort of graph would I get? What would my graph here look like? Straight line.
Bar chart with flat tops.
Bar chart with flat tops. Yeah, you would get here something like that, where that was 1/6. Okay, that is a discrete distribution. Okay, the values it can take, each value has an associated probability. What do we know about the probabilities?
Add up to 1.
Add up to 1. Yeah. Okay, we know that the sum of each of the probabilities adds up to 1. What else do we know about each of the probabilities?
They're all equal.
In this example, they're all equal, yeah. Just for anything, even if that didn't apply. Can you think of something they could never be?
0.
Could be 0 if it was impossible, but they could never be. You're very close. They could never be less than 0. Yeah, okay, that's right. So probability could never be, could not be less than 0. Okay, so that's some discrete stuff. So coming into continuous stuff, so switching now into continuous random variables, which I'm just going to call CRVs for continuous random variables, otherwise you'd spend an awful lot of time writing down long words. What do you think a graph of a continuous random variable will look like?
A line of some sort.
A line of some sort, okay? So a line of some sort, okay? X will be down here. Going with the definition we had earlier on for what continuous was, maybe between two values you had probabilities. So you'll get something like this now for continuous random variables. If there happened to be a value between A and B, which I'm going to call C, what would be the probability that X equals C? And from the information you have got, you should be able to give me the answer as a number. Maybe I'm pushing my luck. Maybe I'm pushing my luck a little bit there. The probability that X equals C. Let's say that that was 2, that was 4. Let's say that X is the length of a pin. Okay. So let's say the question was, what's the probability length of the pin is 3? Let's talk with, maybe we're doing it in centimetres. What's the probability the length of the pin is 3? Anybody going to have a go? 0. Why?
Because to be that exact, you're taking infinitely small, like it. Yeah.
Well, you're going exactly the right line, yeah. With continuous, no pin can ever be exactly 3. If you measured it, you know, even with better equipment than actually you could, it would be 3 point something, 0.000 something, or 2.99999 something. Okay? We actually say that the probability with continuous stuff that it takes any value is 0. Okay? So the probability here that it was 3 is 0. You cannot have probabilities taking specific values. Okay? Specific value probabilities just don't happen. So the probability X is any specific value will always be equal to 0. Okay? So that's one key thing about continuous random variables. So rather than deal with specific values, what do you think we might deal with instead?
Range of values.
Range of values, yeah. So what we do instead is we use ranges. We use ranges. So if we had said what's the probability that the length of the pin was between 2.95 and 3.05, that would have been perfectly acceptable question to ask, okay? That's an okay question to ask within a range. What's the difference between these two lines? I'm just going to pause the recording there.